Hello, everyone, and welcome back to another chemistry video. Since the test is in 2 days, I have more videos, and I'm going to try and condense them so they're not 3 hours long like the chemistry videos we had to watch. But anyway, to get started, I'm going to talk about chemical bonds. So, as we know, chemical bonds are the bonds that form between atoms that hold them together. And so, the formation of bonds depends on electron configuration. So, that's where the electrons are in an atom, and the attraction of atoms for electrons. So that just means how much the atom wants electrons. You know, noble gases don't want any electrons, while the alkali metals want to lose their electrons and halogens want to gain electrons. So it's like that. So the strength of of chemical bonds is the measure, that's spelled incorrectly, of energy needed to break the bond. So basically, the harder it is to break, the stronger it is. So, and bond strength is greater when the difference in electronegativity is greater. And what electronegativity is come back. Okay. What electronegativity is it is the tendency for atoms to attract electrons. If you remember when we learned about periodic trends, the one that went up and this way, electronegativity and electronegativity is just the number, like the measurement of electron affinity. So that's why the noble gases don't want electrons, they're the exception. That's why the halogens are the strongest. Fluorine actually has the highest electronegativity, but cesium has the smallest. So the character bonds is when the transfer of electrons between atoms. Now we know most of that. Okay, so another thing with electronegativity is the max amount is 4, and that's fluorine has the max with 4, and like I said earlier, the difference, I didn't say this earlier, but the difference in electronegativity tells you how strong the bond will be, and it also tells you what type of bond. So say the difference between the atoms was 1.67 through 4, that would be an ionic bond. So the teachers probably gave you a periodic table with these values on it. So if you had, let's say, Oh, that's not ionic. Let's say lithium oxide. I don't even know if that's a real thing. But if you subtracted the electronegativity of lithium minus the electronegativity of oxygen, it would be somewhere in this range, and that would tell you it's ionic. So say it's between 0.3 and 1.67, that would be a polar covalent bond, and then 0.0 to 0.3 would be a normal covalent. So remember, the difference between ionic and covalent is ionic is a transfer in electrons, and covalent is when they share electrons. So that's when this is your non-metal and metal, and this is your two metals. But then what polar covalent is polar is they're not shared equally. There's one atom that kind of hogs the electrons most of the time. So, and then there's also metallic bonds, but we're not really going to talk about those. So that's kind of the rundown of bonds. I guess to note, yeah, the character of bonds is, the type of transfer of the electrons. And so, yeah, that's kind of it. I've decided I'm just going to make short videos and make a bunch. So, yeah, if you have any questions or need more examples or anything, just come talk to me before the test. Be happy to help. And yeah, thank you so much.